For as long as humans have looked up at the night sky, one question has echoed through history. Are we alone? Every star you see, every faint point of light scattered across the darkness, is not just a star, but potentially a sun surrounded by worlds. And yet, despite centuries of searching, listening, and exploring, the universe has never answered us back. No confirmed signal, no undeniable proof, no alien civilization waving from the stars. Only silence. But is that silence empty? Or is it hiding something far greater than we can imagine? Tonight, we begin a journey from the birth of the universe to the edge of known space, to the deepest question science has ever dared to ask: how big the universe really is. For most of human history, we believed Earth was the center of everything. Ancient civilizations placed our planet at the heart of creation. The sun, the moon, the stars, all revolving around us. But in the early 20th century, that belief was shattered forever. In the 1920s, American astronomer Edwin Hubble made a discovery that permanently changed humanity's place in the cosmos. Using the Mount Wilson Observatory in California, Hubble observed faint, cloudy objects called nebulae. At the time, scientists believed these nebulae existed inside our Milky Way. Hubble proved they didn't. They were entire galaxies, unimaginably far away. In a single moment, the universe exploded in size. The Milky Way was no longer everything. It was just one galaxy among many. The observable universe is about 93 billion light-years across. That means the light reaching our eyes tonight began its journey before Earth even existed. To understand how extreme this is, consider this. Light from the sun takes 8 minutes to reach Earth. Light from the nearest star takes 4.3 years. Light from distant galaxies takes billions of years. If intelligent civilizations exist far away, their signals may never reach us, have already passed Earth millions of years ago, or arrive long after humanity is gone. Space is not just big, it is brutally isolating. And this leads us to a critical realization. The universe may be full of life, but completely disconnected. If the universe is this vast, if planets are this common, then the real mystery is not whether life exists. The mystery is, why did life appear here at all? Before we search for alien life, we must answer a dangerous question. What even counts as life? In 1994, NASA proposed a working definition. Life is a self-sustaining chemical system capable of Darwinian evolution. Simple, but incomplete. This definition assumes life must use chemistry, reproduce, evolve over time. But what if alien life doesn't follow Earth's rules? What if life exists as exotic chemistry, artificial intelligence, energy-based systems we don't yet understand? By limiting our definition, we may already be missing the answer. In 1952, scientists Stanley Miller and Harold Urey performed a revolutionary experiment. They simulated early Earth's atmosphere: water vapor, methane, ammonia, hydrogen. Then they added electric sparks, mimicking lightning. Within days, the experiment produced amino acids, the building blocks of life. This proved something extraordinary. Backhand index pointing right: life's ingredients form naturally. No miracle required. Carbon bonds easily. Water dissolves chemistry. Energy drives complexity. If this happened once, it can happen again. Can life exist without Earth-like conditions? For decades, scientists believed life required sunlight, warm temperatures, calm environments. Then came the discovery of extremophiles. In the 1970s, 1990s, life was found near boiling hydrothermal vents, frozen beneath Antarctic ice, inside radioactive waste, deep underground with no sunlight. Life didn't just survive, it thrived. This shattered the idea of habitable zones being narrow and rare. It suggested something profound. Life is not fragile, it is relentless. How life began on Earth. 4.5 billion years ago, Earth was hell. The surface was molten. Asteroids slammed into the planet non-stop. The atmosphere was toxic. The oceans boiled. By every logical measure, Earth should have been lifeless. And yet, in rocks over 3.5 billion years old, scientists have discovered microbial fossils, tiny structures that could only be made by living organisms. That means life appeared almost immediately after Earth became stable. In cosmic terms, that is not slow. That is instant. This discovery terrified scientists because it suggests one of two things. Life is incredibly easy to start, or something pushed it into existence. Either answer changes everything. For nearly 2 billion years, life on Earth remained simple. Single-celled organisms ruled the planet. No eyes, no brains, no thoughts. Then something extraordinary happened. About 540 million years ago, life suddenly exploded in complexity. This event is known as the Cambrian explosion, identified in the 19th century through fossil records. In a relatively short time, eyes appeared, skeletons formed, predators and prey evolved, complex nervous systems emerged. Life learned to see, think, and react. Eventually, intelligence followed. But here's the unsettling part. Intelligence is not guaranteed. Dinosaurs ruled Earth for 165 million years and never developed technology. Humans have existed for just 300,000 years. A blink of an eye. In the 2000s, scientists studying ancient rocks found carbon isotopes that strongly suggest life may have existed 4.1 billion years ago. That is almost as soon as Earth cooled. This implies that life doesn't need perfect conditions. Life doesn't need long timescales. Life may emerge wherever conditions allow, rapidly. If Earth is not special, then life should be common. And if life is common, then the universe should be alive. So once again, we face the same question. Where is everyone? Until 1995, we had never confirmed a planet outside our solar system. Then astronomers Michel Mayor and Didier Queloz made history. They discovered 51 Pegasi b, a planet orbiting a sun-like star. This discovery proved something revolutionary. Planets are common. Since then, missions like Kepler and TESS have identified over 5,000 confirmed exoplanets, with tens of thousands more candidates. Some are rocky like Earth, covered in oceans, orbiting within habitable zones. Earth-like worlds are not rare. They are normal. In the 1950s and 60s, scientists introduced the idea of the habitable zone, the region around a star where liquid water can exist. Too close, water boils. Too far, water freezes. Earth sits perfectly inside this zone. But modern discoveries have complicated the picture. Planets don't need Earth-like atmospheres. Earth-like if life can exist beneath ice, without sunlight. In 1961, astronomer Frank Drake created an equation to estimate how many intelligent civilizations might exist in our galaxy. The equation includes star formation rates, planet frequency, habitability, life emergence, intelligence, technology, longevity. Depending on the values you choose, the answer ranges from 0 to millions. The universe allows both extremes, and that uncertainty is terrifying. In oceans across the solar system, then intelligent life may not be rare. It may be inevitable. So why hasn't it revealed itself? In an optimistic universe, life is common. Intelligence emerges easily. Civilizations communicate. In a pessimistic universe, life is rare. Intelligence is fragile. Civilizations self-destruct. Both models fit the evidence. Because right now, we have one data point. Us. Why we haven't heard anything yet. In 1950, physicist Enrico Fermi asked a simple question. Where is everybody? This became known as the Fermi Paradox. If intelligent life is common, if civilizations last long enough, if space travel or communication is possible, then the galaxy should be full of signs. But it isn't. At least, none we can confirm. What if the silence isn't empty? What if it's a warning? The Milky Way galaxy is over 100,000 light-years wide. It contains more than 100 billion stars. Even if intelligent life arose on just 1 in a million planets, there should be thousands of advanced civilizations in our galaxy alone. And yet, no alien probes, no megastructures, no confirmed signals. This contradiction between high probability and zero evidence is the heart of the Fermi Paradox, first articulated in 1950 by physicist Enrico Fermi. It forces us to confront an uncomfortable possibility. Something is preventing civilizations from lasting. In 1998, economist and philosopher Robin Hanson proposed one of the darkest solutions to the paradox. He called it the Great Filter. The idea is simple and terrifying. Somewhere between lifeless matter and galaxy-spanning civilization, There exists a nearly impossible barrier, a step so difficult that almost no species passes it. Possible filters include: life rarely begins. Complex cells are extremely rare. Intelligence is unlikely. Technology leads to self-destruction. And here's the question that haunts scientists. Have we already passed the great filter, or is it still ahead of us? If it's behind us, we are incredibly lucky. If it's ahead, then our future may already be doomed. Are we early or already doomed? The universe is 13.8 billion years old, but stars like our sun will continue forming for trillions of years. That means we are living at the very beginning of cosmic history. So why would intelligent life appear so early? Some scientists propose a chilling answer. Most civilizations don't last long. They rise, they discover technology, they collapse, and disappear before the universe becomes crowded. We may not be alone in space. We may be alone in time. In 1960, astronomer Frank Drake launched Project Ozma, the first scientific search for extraterrestrial intelligence. 2 nearby stars, simple radio antennas, total silence. Since then, SETI has listened to millions of stars across decades. They search for repeating radio patterns, narrowband signals, artificial structures and data. So far, nothing confirmed. But silence doesn't mean absence. It may mean we're listening the wrong way. On August 15, 1977, a radio telescope at Ohio State University detected a signal so unusual it stunned scientists. It was strong, narrowband, non-random. Astronomer Jerry Emmons circled the signal and wrote one word beside it. Wow! The signal never repeated. To this day, its origin remains unknown. Not proof, but not explained. A whisper from somewhere. In 1960, physicist Freeman Dyson proposed a radical idea. Advanced civilizations might build massive structures to capture their star's energy. These Dyson spheres would leave detectable infrared signatures. Modern telescopes have searched. Some strange stars exist, none confirmed as artificial. But the search has only just begun. We are children with new instruments, listening to a universe that may speak very softly. Between 2020 and 2023, the U.S. government declassified multiple reports about unidentified aerial phenomena, UAPs. These objects, accelerated without visible propulsion, outperformed known aircraft, defied easy explanation. Important clarification: unidentified does not mean alien, but it does mean we don't understand everything in our skies. And that matters. Science does not dismiss claims. It tests them. Extraordinary claims require extraordinary evidence. So far, no verified alien craft, no confirmed alien bodies, no repeatable proof. Curiosity must walk hand in hand with skepticism. Otherwise, belief replaces truth. Could aliens already be here? In 2017, astronomers detected something unprecedented. An object from outside our solar system. It was named Oumuamua. It showed no typical comet tail, strange acceleration, an unusual shape. Some speculated it could be artificial. Most evidence suggests a natural origin. But the door cracked open. Interstellar objects are real. And we noticed this one late. What if we don't need to look to distant stars? What if life is already close? Mars was not always the frozen desert we see today. Billions of years ago, Mars had rivers, lakes, possibly oceans, a thicker atmosphere. In 1976, NASA's Viking landers became the first missions to search directly for life on another planet. The results were confusing. Some experiments hinted at biological activity. Others contradicted it. For decades, the question remained unresolved. Then came a new generation of explorers. In 2021, NASA's Perseverance rover landed inside Jezero Crater, an ancient lake bed. Its mission: search for fossilized microbial life, drill samples, store them for future return to Earth. If even dead microbes are confirmed on Mars, it would prove life formed twice in one solar system. And that would mean life is not rare. It is universal. Mars is not our best chance. The real candidates lie beneath ice. Jupiter's moon Europa and Saturn's moon Enceladus contain vast subsurface oceans, warmed by tidal forces. In 2005, the Cassini spacecraft flew through plumes erupting from Enceladus. It detected water vapor, organic molecules, hydrogen, a potential energy source for life. On Earth, where there is water, energy, chemistry, life follows. These moons may host alien ecosystems right now, not civilizations, not technology, but something alive, breathing in the dark. What first contact would look like? Forget movies. Real first contact will not be dramatic. No invasion, no landing, no message in English. It will likely be a chemical signature, a fossil, a microscopic organism. And yet, it will be the most important discovery in human history. In 1989, scientists created SETI post-detection protocols, guidelines for how humanity should respond to confirmed extraterrestrial life. They emphasize verification, transparency, global cooperation, because discovery will not belong to one nation. It will belong to all of humanity. There is a possibility few like to discuss. That life arose once, here, and never again. In 2000, scientists Peter Ward and Donald Brownlee proposed the rare Earth hypothesis. They argued that complex life requires a stable star, a protective giant planet like Jupiter, a large moon to stabilize climate, plate tectonics, a magnetic field, perfect timing. Miss one factor, and intelligence never appears. If they are right, then humanity may be cosmically unique. Does that make us special or fragile? In the 1970s, physicists discussed the anthropic principle, the idea that we observe the universe the way it is because we are here to observe it. But this is not comforting. If intelligence is rare, then extinction is permanent. No second chances, no replacements, no backups. Every war, every climate shift, every existential risk suddenly matters more because the universe may never try again. In 1967, nations signed the Outer Space Treaty, committing to peaceful exploration and planetary protection. Why? Because contamination works both ways. We could destroy alien life before discovering it. Or worse, bring something back we don't understand. If we are alone, then preserving life becomes a cosmic responsibility, not just for Earth, but for the universe itself. In 2022, the James Webb Space Telescope began analyzing exoplanet atmospheres. For the first time, we can detect water vapor, carbon dioxide, methane, potential biosignatures. We are no longer guessing. We are measuring. Within decades, we may know which worlds are alive, which are dead, which resemble Earth. The answer is coming. Future observatories like the Extremely Large Telescope, the Square Kilometer Array, will process more data than humans can analyze. AI will listen where we cannot. Projects like Breakthrough Starshot, announced 2016, aim to send tiny probes to nearby stars within a human lifetime. For the first time, interstellar exploration is not science fiction. It is engineering. How long until we know the answer? We may find microbial life within 20 years, technosignatures within 50 years, or nothing ever. Science does not promise comfort. It promises truth, and the truth may be closer than we think. Are we alone, or just too early? The universe is young. Civilizations may rise millions of years apart. We may be the first, or one of many, separated by time. Silence does not mean emptiness. It may mean patience. After centuries of searching, the question remains unanswered. But that does not mean it is unimportant. It means it is the most important question of all. If this question moves you, if the universe feels bigger now, like, subscribe, share, because the answer